Hello, my little AP Environmental Science darlings. I know you're back here to learn a little bit about evolution, a little bit about ecology. It should all be review of 10th grade, and I know you're excited, I'm excited, and this person's excited because they are punching a kangaroo, so let's celebrate by boxing a kangaroo. Alright, sweetums, this is a review of what does the actual word evolution really mean, and the formal definition of evolution, really, the big key word here is change. When something evolves, it is changing over time, and evolution is the study of how living organisms have changed and their genes have changed over time. And so guess what? When you've got 4.5 plus billion years on Earth, there's a lot of time for changes to happen, even if the changes are slow. And so we got here our little tree of life, and here we are with like a walking stick or some sort of wizard stuff, not sure, but we're all kind of changing from a variety of different earlier forms, and there's been a lot of different varieties of changes that have resulted in a variety of different types of animals, and this is a very simplistic form of life, but it's very interesting. So, evolution is change. So the next question is, what the heck is evolution actually changing? And the answer is dolls. No, I'm only kidding. It's not actually changing these dolls, but you've seen these little dolls before, and they've got like some Eastern European name that I can't pronounce, but you put this one and this one and this one, and so they all kind of fit in this, and these are what... It's kind of a little metaphor for what these words are: individual, population, community, ecosystem, biosphere. They all kind of fit amongst each other. And the question is, which one is doing the evolving? And actually, the evolution forces evolve on the individual, so the first smallest piece. So here's a little visual here to show us how all those 5 pieces fit together. So we got this little lone baby caribou drinking coffee all by itself. This is the individual, and evolution actually changes individuals. So there's one caribou that looks a little different than this caribou, And then when we put all the caribous together, they have a caribou coffee drinking party, and that's what we call a population, a group of individuals of the same species. Then the caribous, they all sit around in the same place with all the snow geese and all the polar bears, and I don't think they're like hanging out and like having dinner because like one of them is each other's dinner, but all of the living populations together as a community. Then we add all of the living things together and combine it with all the non-living things that they all seem to like, which would be like ice and water and mountains, and this is what we call an ecosystem, specifically the tundra ecosystem. And then we put all of the ecosystems together on Earth, and we've got the world, the Earth, the biosphere, Mother Earth, la la la, biosphere. So now that we know that the cute little baby caribou all by itself on the tundra is the object of evolution's desire, and it's not the whole group of caribou that are evolving all together at once, the question is, what is the theory that drives or the prediction of how evolution works? And there's this guy, you may have heard of him, his name is Charles Darwin, good old Chuck in the house, Chuck Darwin, and he predicted that evolution occurred via natural selection, and it basically is explanatory in its name, is that nature, oops, I'm moving the screen around, nature is basically doing the selecting. So some creatures will live, some creatures will die, and if we look at all those caribou, each individual caribou may look alike, but they're pretty different from each other. Some have bigger heads, smaller heads, bigger tails, bigger feet, smaller feet, etc. There's a lot of variation. And where's this variation coming from? It's their genetics, and some of them are mutated or have mutations or differences from each other. And sometimes these changes are really helpful, and we call those an adaptation. And so if you have an adaptation that helps you to survive in your environment, that's a good thing. And sometimes you're born with some weird mutation that does not help. Like, for instance, maybe that caribou was born with lead feet. That may not be very helpful, so then that would cause it to probably die pretty quickly. And ultimately what happens is those that have really helpful mutations or adaptations will likely survive. And if you survive, you get more shots at making sweet babies. That's right, I said babies. This is the only time I like babies. And more babies means that you're going to pass that advantageous trait onto the next generation, and then they'll probably survive better and pass it on, and you'll keep seeing this over and over and over again. So let's apply this idea of natural selection to an actual real example instead of lead-footed caribou people, which is scary. And so I picked owls because you know what? Owls are freaking cool. And they've got so many amazing adaptations, and one of the cool ones is that owls are really silent when they fly, which most people don't realize, but that's true. And one reason that they're silent is because they got these really weird feathers. I mean, what's going on with these feathers? Do you ever pick up a feather in your yard? It doesn't look frayed and kind of like dirty, dusty like this. But apparently, a long time ago, a little baby owlet was born and kind of had this weird mutation where it had some like kind of dusty looking feathers. So we've got this dusty owl-like creature with little frayed feathers, and all the owls would make fun of it, and they wouldn't let play any of the owl games, just like Rudolph and his reindeer games. And no, that's not actually what happened. What happened was some sort of owl had this mutation with these just slight, and it's not a very noticeable mutation, with these slightly frayed feathered tips. But it turned out that when that little owlet flew, it didn't make any noise, which is kind of convenient if you're a nocturnal hunter, because when you're trying to hunt something and you don't make noise, guess what? You're probably going to be pretty successful hunting it. So that's what happened. And that owlet with that strange mutation survived and likely had babies, and guess what their babies had? The same type of feather structure. And so you do this generation after generation after generation, and this trait shows up more and more and more each generation because it enhances the survival of those who have it. And we see the ones that don't have it less and less. And ultimately, over time, this mutation becomes kind of an inherent part of what we know as an owl. I love you, Hedwig. Aren't you so cute? Yeah, yeah, yeah. Owls, yeah. So now that we've talked about that evolution is this change, and it's mostly driven by natural selection in most cases, everything is basically evolving in response to its environment and to each other. And so that's kind of cool, because basically as everything's evolving, things change, and then other things change in response. And we get this thing known as coevolution, where creatures are basically evolving in response to each other. And there's so many amazing examples of this. We've got pollinators, where the flowers evolving to help attract the pollinating creature, in this case the hummingbird, and the hummingbirds evolving to help extract in a way, or changing in a way over time to help make it easier to extract the goods out of the flower that the flower provides it. There's this cool example, which this newt is incredibly toxic. It has huge amounts of toxins which can kill many human men. And the reason is why, well, it turns out they've kind of been evolving higher amounts of toxin in response to snakes that have been eating them, which have been evolving higher amounts of immunity over times, over many millions of years. So this coevolution is pretty cool, and is really what shapes how our world looks today and how it will look in the future. So with all this friggin' evolution going on, and all of these different creatures that exist on Earth, and they're all responding to each other, there's just so much coevolution that we have such an immense amount of different relationships between organisms out in the natural world, and they get complicated, and there's just so many different kinds. And what we want you to know is the different kinds of relationships that can exist between organisms. And these you should have already learned here, and we kind of group the 5 big ones: parasitism, commensalism, mutualism, predation, and competition. We'll talk more about them in a second. We also want you to know that some of these relationships are very intimate. Ooh la la, it sounds so, ooh, so scandalous, but it's really, when we say intimate, we're saying that they're just closely related to each other, or they interact with each other frequently in this relationship. And that word for that close relationship are symbiotic. So these 3 are symbiotic. And then relationships that occur between organisms but are not really intimate or close, we call non-symbiotic, and that would be the predation competition group. So the final little bit here is just to review what these 5 interactions are. We're going to start with the symbiotic species ones, so the intimate ones. All right, lots of kissing in this one. Well, hopefully not, because the first one we got is parasitism, and who wants to kiss a parasite? Eek! Parasitism is when one organism in the relationship really highly benefits off of another one that's receiving harm. Now, keep in mind that the harm is not an immediate death, but it could be slow energy suckage from the other one. So perhaps the other one's taking blood or body fluids or energy away from the other one over time, and slowly weakens it. But parasitism, one is getting a definite advantage, one is not. And of course, who doesn't love a good parasite? I love parasitism because the pictures are gross. A good example is the tapeworm here, and this comes out of something's butt. And here's an example of it right there. You consume the tapeworm sits inside and eats away your energy, this poor dog here, and then ultimately ends up providing it a benefit, but the dog is weakening over time. So parasitism, very intimate, obviously. Commensalism is another intimate one, but one where only one of the creatures really gets a benefit. So in this case, a good example is cattle and cattle egrets. The cattle don't really get a big benefit from this. The cows walk through the fields and they're just eating grass. They don't care. They don't want to eat the egret. They're just eating the grass. But the egrets walk around, as you can see, right next to the cattle. And basically, because cows are so big and chunky that when they move, all the stuff in the grass is like, ah, cow, and they move out of the way. And then those small little creatures that move away from the cow are good pickings and eats for the egrets. So the egrets get a meal and get free, basically, prey services from the cows, but the cows don't really get much from the egrets. So that's a good example of commensalism. The next symbiotic interaction is mutualism. And mutualism means that everybody benefits. Yay! It's a win-win. And there's so many amazing examples. Pollinators and their flowers are a good example of mutualism. I'm picking two that are unique, that are also kind of important for environmental science. Mycorrhizae is a great example of mutualism. Say it with me. Mycorrhizae. It's fun, isn't it? And mycorrhizae is the very fancy word for a relationship between fungus and plants. So basically, this little plants over here were not grown with mycorrhizae, and these do have mycorrhizae where the plant is also connected with this fungus. And the fungus grows in the root systems, and it basically makes the roots bigger. And so the good thing is the fungus needs food. So if it's connected to the plant gives it food. So that's the plus that the fungus gets. The benefit the plant gets is the fungus grows and makes the root systems bigger, which means the plant can pick up more water and nutrients to help it make more food. So the plant gets extra food and water, or water and nutrients as well from the soil, and so it's this plus. Another interesting example, which happens a lot, is gut mutualism. So mutualistic relationships where like bacteria are living inside of the gut or the stomach of creatures. So this could be like cows. Cows, when they chew their cud and they have 4 stomachs, in the stomach is bacteria to break down a lot of that material. What do the cows provide the bacteria? They provide a house or a stomach for the bacteria to live in and some extra food and resources that they might need. The bacteria in turn give the cow, help break down some of the food that is the cow's not able to digestively break down, and gives it some extra nutrients. The same thing happens with these little creatures here. These are termites. Termites eat wood. Wood is not very digestible, but they eat the wood because inside of their stomachs are the little bacteria that help break it down, and the bacteria get a lovely little stomach home. Isn't that great? Finally, the last 2 interactions are non-symbiotic. So the first one is predation. So this is not very intimate because the relationship, to be honest, does not last very long. Predation means one thing is eating another. So the relationship is not long and complicated. It is one thing literally bites and kills and consumes the other. So here's a very morbid example right here. Poor thing. All right, this is a cool one. The archer fish shoots off the insects into the water and then eats them. So predation is a plus-minus. One's getting a plus, called food. One's getting a minus, which is called death. It's not intimate because it's pretty immediate. And the last one here that's non-symbiotic is competition. This is a relationship that occurs, but it's often maybe not direct. Things compete with each other, but they may not compete with each other face to face. But they're both negatively impacted because when you compete for something, either you're going to have to fight over it, which could cause problems, or you have to share, which means you don't get what you want all the time. So both parties are not getting what they want, which we often consider a negative. There's kind of 2 types of competition out there. There's interspecific and there's intraspecific. Specific means species, and inter, like an interstate, means multiple different states. So if you drive an interstate highway, you're driving a highway that goes through many states, like I-35. So interspecies competition means competition between many different species. So here's our little example here. The hyenas and the lion, two different species of creature, are fighting over this carcass. They want food, they don't want to share it, they're fighting or they're competing for the same resource, and they're different species. If you are the same species competing over the same resources, we call this intra-species competition. And often that means like a lion and a lion are fighting amongst each other, or a hyena and a hyena are fighting amongst each other. And this means that when you've got creatures of the same species competing, they often set up territories to avoid competition or try to parse out the resources. And this is an example of a lion spraying a bush, and I would not want to be on the end of that bush. That looks frightening. So hopefully you remember all of these key points of evolution. You remember the key 5 interactions. These are all from 10th grade, but hopefully you got a quick refresher here. And now go ahead online and click that link and answer the questions with your apps account open. Goodbye.